Smurfs getting on my space elevator. They would cause a lot of trouble, I'm sure, but it's good.
I think we need a Christopher Nolan movie to explain this to most of the people, because
not Alina and me are always willing to test ourselves and go first.
And in the previous episode, they also already sent me to space.
But I like simple. Simple is good.
Yeah, I kind of also had this feeling when you spoke about, they didn't want to hear about it, but that is what they got.
Hello everyone, and welcome back to the season 2, episode 4 of Smurf House, a podcast where we mostly discuss about space stuff, but we also end up rambling about a range of other topics, like from K-pop to NFTs. And this is your potentially spaced out space person, Alina, and
Pooja here, who is your wandering stargazer. And with space flights and space tourism coming into discussion, people might be very new to the concept of a space elevator instead of space rockets and space shuttles. So today, on our 4th episode, we have an interesting topic to discuss, and an amazing person and an expert is going to be joining us as well.
Exactly, you're so right. And a space elevator, have you guys thought about it, ever? I mean, apart from the fictional stories and movies that you might have seen, I mean, it's real. Trust me, this is not a fiction that you're listening to. And in this episode, we will be talking about this intriguing concept of space elevator and how it transforms the movement of planet. And to give more insights about this and how it works, we have Dr. Peter Swan here.
And I'm very, very honored to invite Dr. Swan, who is the president and board of director member of the International Space Elevator Consortium. And he's also the senior vice president at the Galactic Harbor Associates. Thank you, Dr. Swan, for joining us today. We're really, really excited to talk with you about this.
Well, you're welcome, because I love the idea of the Smurfs getting on my space elevator. They would cause a lot of trouble, I'm sure, but it's good that we have a little. Now, I did wear my blue shirt, so I'm trying to get into the mood here. But the real kicker is that the future of humanity will be outstanding, because we will help save the planet with space elevators, and we will move off planet robustly. We call it the green road to space because we lift everything with electricity. But it's a permanent infrastructure. It's like a train infrastructure. So it's going to be transformational in an extreme. It's good. We're going to respond to the customer needs. We're going to be able to lift 30,000 tons per year once we get up to initial operations. Now, just to put that term in perspective, we've only launched like 26,000 tons since the first Sputnik. So we're going to put up in a year more than we've done as a human race at that point. So we're going to respond to the customer needs. It's an infrastructure. And one of the ones that's out there is space solar power, where we can actually lower the temperature of the atmosphere. And they can do it by sending energy down from space. We can deliver a lot easier and more robustly and a lot better schedule than individual events. We will also be able to move off planet and get to Mars. Let's think about this a little bit. We did a study with the Arizona State University, and they did a study and looked at going to Mars, and they figured out that instead of waiting 26 months, they could release toward Mars every day. Wow. In addition, we can get there in 61 days. The current approach for NASA with the Hohmann transfer is only like 7, 8, 9 months. We can do it in 61 days. Now, that's the best, but we average about 100 or so. Wow. And we can move massive amounts of cargo toward Mars. So we literally can help Mr. Musk out. And that's the point. What we want to do is we want to create a dual space access strategy. So we have the strengths of rockets, move people through the radiation pass. We have the strength of space elevator, massive movement of cargo rapidly to where we want to go. And we combine them. And then we have a delightful architecture moving cargo to where the dreams are. And so that's really what we want to do. But let me first start with the Galactic Harbor Associates. She mentioned that I'm a vice president there. We are starting to build a space elevator. Now it's embryonic. We don't have much money. but we're starting. Now, the first idea was in 1895. You know, that's so last century, not even last century, that last century.
Yeah.
Russian came up with the idea, and then in 1960, another Russian enhanced it. Then came along Dr. Pearson from the USA in 1975 or so. And then we had 2002, Brad Edwards, Dr. Edwards said to NASA that we can build it. NASA didn't want to hear that, but that's what he told them. And we had to wait for the material. And at that time, the material wasn't there. But now the material is there, and we're in the process of developing. So the space elevators are really a transformational permanent infrastructure providing access to space to enable Mr. Musk 1 million tons to Mars, Mr. Bezos building a road to space, the National Space Society have a L5 location, a spinning colony in space, and also space solar power. So we really are able to provide the capability of moving mass.
So a couple of things which you said, Pete, really stood out for me. Number one is when you mentioned the sentence, delivering cargo where dreams are. And I felt like that really hit me really hard. That is so well thought out as well. In fact, you kind of addressed the first question that I had in my mind. When I heard about space elevators, it was a new concept. And I really was curious to know about its origin and who was the first person to talk about it. And like you said, it was the Russians, and then we go forward. I kind of also had this feeling when you spoke about, they didn't want to hear about it, but that is what they got. And I always feel whenever there is some new technology that we are speaking about, the first questions or the first time you're just lashed out saying, is this not obsolete? Why is this important? Why do you want to do that? And you were also speaking about how, it's going to help with the environment, and, it's a green initiative. So could you kind of maybe speak about when we started off in terms of like the journey of space elevator? You said that now we have started building. Number one, what is it that has changed that we've started building the space elevator now? And how has the journey been in terms of like from the original concept to now being able to build it? What have been the major roadblocks? If you could start off from there.
No, excellent. Yes. The Galactic Harbor Associates is we started a company to build a space elevator. Now, at the present time, we are laying out engineering test plans. We're laying out programmatic teams to be able to lead the engineering test plans. We're laying out policy and procedure aspects with respect to governments. How do we interface with the international governments? How do we interface with space law? How do we get a slot at geosynchronous for communications? All those areas are part of the thing. So we're laying out the plans. We haven't built anything in the sense of hardware right now, but we're within 2 to 3 years of starting hardware, building and testing and all that kind of stuff. The real key to the development of the space elevator is the space tether. And the tether is what we're at right now. And I was just at the University of Manchester in England, and they're in the process of developing a process to have a continuous roll of single crystal graphene. That's a 2-dimensional material, a brand new material, 15 years or so. And that material will be able to be strong enough, long enough, and light enough to be our tether. So we have a tether on the drawing boards. We don't have it yet, and we're working that, but we don't plan on our operations until 2037. So we're a little ways away, and so we don't have to start bending metal today. What we have to do is plan well, and that's where we're at. We're kicking off the space elevator development program in the planning phase.
I mean, that's so interesting to hear about. And
Alina, when he just said that they've started working with space lawyers, in my head, I was feeling like, thank God there will be some future jobs for you and me.
There will be plenty.
I was about to mention that you should go there. But yeah, I mean, it will be so interesting, like, if this becomes like, if this gets constructed and we have our very first cargo being transported from Earth to, let's say, to Moon or Mars, like Mars, yes, I'm rooting for Mars. Yeah, so if that happens. And my second question will be like, from the application perspective, which you might have also covered, like, but for the audience to make it a little more clear, why exactly do we need a space elevator? Like when we have like rockets and other space shuttles that are being sent from Earth to space? And what are the potential issues that they are solving, like the space usage of space elevators?
Okay, the space elevator is like a train. It is a permanent infrastructure, so it's not a single event. A rocket, let's just use geosynchronous, the altitude way up there where the communication satellites are. The rockets only get 2% of the mass on the pad up there, and they only launch to that orbit about once a month. When we get a space elevator that has a daily liftoff of massive cargo, they can deliver 70% of the cargo to geosynchronous, and then they reuse the other 30%, which is the tethered climber. So we're talking about reusability, and we're raising with electricity. So we do not burn anything in the atmosphere. So the pollution from each individual rocket is eliminated. So we need rockets because they're our partner. We need them in our dual space access architecture. We need rockets to move people and stuff like that. So that's no problem. We got to do that. But what we want to do, space elevators want to do the heavy lifting. And that's the characteristic of space elevators. Heavy lifting, daily, routinely, inexpensive, safely, and environmentally friendly.
Yeah. I mean, in that case, like if I'm not wrong, I heard it right. Like we use electricity for communicating, like
Right.
transferring. Oh, that's
it's a box that has a cargo in it. Then it has two wheels that press against the tether. You turn the wheels with friction, it goes up. The electricity comes from the sun with the solar arrays. So you drive the box and the motor and the wheels with electricity from the sun. So you're not burning any rocket fuel at all. And so you're saving our environment as well as raising massive cargo daily.
I'm
That's
so
why we call
impressed.
it the green road to space.
I'm like so impressed.
I even like go to my next question. I feel like every time I speak to you or you speak, there are some new questions that pop in my head, and which is so good. I feel like the mark of a good discussion is always when you're left with more questions, than answers. And I was just wondering, with the kind of technology that you just spoke about in terms of like a completely green technology where you're using solar power to, harbor the electricity and send something which is of that massive, mass up in space. What do you think would be the fallouts of the application of such technology? Because I usually see that in space, we always try and develop some new technology, and then there is applications of it throughout where we wouldn't even have thought of. Like, your something that everyone uses almost every day, or foam beds that we sleep on, was something that was actually a fallout from space tech and space science, right? Which not too many people might know, but day-to-day life in space has really touched us. So in that sense, where do you think this kind of technology might actually be used in the future?
Well, it's a train-like technology. So it's more moving the technology, enabling people to build businesses and stuff. Let me give you an example. We go up to geosynchronous in 5 days in a nice, easy ride up with electricity. You get up to geosynchronous and you float out of the tethered climber. You are now in an environment where you can develop a business. You can repair old satellites. You can replace solar cells. You can put new thrusters on and refuel the satellites that are up there. So you can double or triple the lifetime of the satellites that are up there. So there's a whole bunch of refurbishment. And then you can assemble satellites up there and make them huge. We could make an antenna as big as you want because you bring the parts up and assemble them at zero G up there at geosynchronous. So the point is we're going to put a train across a river. And the economic on both sides will blossom. New businesses, new people, new stores, new concepts. And so what we do is we enable phenomenal economic increase in space because we have a transportation infrastructure instead of one at a time. And because we can take a lot of stuff up there.
Yeah,
Wow.
that's
Possibilities are just mind blowing.
exactly.
Oh, I agree. I still get mind blown all the time on this thing.
I'm imagining this, this small shuttle-like thing, taking that, and it's slowly going upwards, and we get images from different satellites that it has reached this orbit. Like, wow, in the future, I'm kind of seeing the future where we actually use a space elevator. Wow. It's so
Ground to
nice.
Alina, to Alina, come back.
It'll transform. Yeah, it'll transform. Let me give you the example of space solar power. Remember, space solar power is supposed to save our environment. Right now, the minimum size of a satellite geosynchronous is 2,000 tons. Remember, we've only put up 26,000 in the history of humans. So 2,000 tons. They always talk kilograms, not tons, when they talk about spacecraft. Just think of that a little bit. Okay, so a space elevator can do 2,000 tons in about 50 lifts or something. That's bad math. Something like that. That'd be 50 days. And rockets can't do it in anywhere near that time, nor can they lift it effectively. They only get 2% to geo of the mass on the pad, where we get 70% of it. So it transforms the way it occurs. It's not just a replacement. I mean, it enables dreams of many.
I think anyway, every podcast I have something to relate to. And this space elevator is getting me to relate it with, how we used to write letters. Like in the beginning, it was birds, like we used pigeons and, things like that to communicate, to write letters. Then we had mailbox where we wrote letters to people if you want to send to them. And now with a click on your hand, you're able to communicate with one person from other side of the world to this side. So I think the space elevator is also something like that. Like earlier, it was so impossible to send something to space. And then we had if you also consider the aviation, we had flights, the first man-made flights, and then we use rockets, and now the space elevator. So I think it's going to get more transformed, and possibly maybe in future, I don't know when, but it can be within the click, you can even jump from Earth to Mars.
Yeah, wow. You cannot comprehend the improvements in outer space when we do space elevators. I mean, it's just going to be remarkable. Just, the students at Arizona State University, when they did the study on how do we get to Mars with the 61 days rapid transit and all that kind of stuff, they did something silly and then presented it to me in their presentation, which was they came up with a daily schedule from the Pacific, Indian Ocean, and the Atlantic, 2 in each galactic harbor, so 6. They came up with a schedule of departures and arrivals on Mars. So if somebody wanted supplies on Mars, they just call up, I want to leave Indian Ocean number 2, 7 p.m., release it, and it'll show up in 61 days. So they give us a train schedule. Now that tells you the difference. That tells you the difference. We're talking about a transportation concept, not an individual event.
Exactly. That is just amazing. And thank you for that beautiful analogy, Alina. I think that was very well put in terms of correlating how technology transforms over the years. In fact, we know that it just took us about 100 years. It was quite a leap from the first manned space, aviation to a space flight. That was just 100 years. And I can't even imagine if a space elevator comes into picture. That makes me think about my next question, which is, space tourism. How is that going to change the space tourism game? Do you think we would start using space elevator for space tourism more rather than using rockets? Do you think it will sort of somewhere replace them, or do you think it will work together?
I believe that it will be incremental. The first priority will be moving mass up to geosynchronous to save our planet and the atmosphere. I believe that's our first customer. And then we're going to have customers at the moon and Mars, and we're going to want to do that. So I think what we'll do is we'll supply them with logistics, because that's our strength. Now, the movement of people would require another design on top of the preliminary design to have redundancy for people and safety issues for people. Now, the Japanese have actually designed that. The Obayashi Corporation has a space elevator design for 100 people and 100 metric tons going to geosynchronous. So they already have the people in the equation. That's about 15 years past what my design is for robotics in moving of cargo, because they have to have two tethers next to each other, safety, right? Redundancy. And that's just one step. Whereas I can use both for moving cargo, which is revenue. So I want to use revenue and move cargo and let rockets take people. They've done a very, very good job with rockets and people. So let's let them continue doing that. And then in 15, 20 years after we get operational, we'll be putting up people movers that go on space elevators. But that's, you know, that's the next step down there. But it's conceivable. It's just like you make one train, you put mostly logistics on it, and then you bring a fast super train, you know, and you bring it along with all the people in it. So, you know, it's just logistics, it's transportation. What we're trying to do is get people to change from liftoff to a train schedule. Routine, daily, et cetera, et cetera, et cetera. You know, think like a train, not individual rockets. And that's the transition we want to have happen in the mind, so that you say, wait a minute, I can get 30,000 tons to my place on Mars in 1 year if I do it this way.
Wow. I mean, all I can think of,
a lot of mass to Mars.
Exactly. And all I can think of is how, because you have been mentioning about it's kind of like trains. I can only think of like, you know, train transportation, like there are like, you know, cargoes and, you know, cars, and then there is passenger trains and things like that. And we both, me and Pooja, we are also rooting for space tourism. And in the previous episode, they also already sent me to space. So I think
I'll go with you.
Oh, yes, we are getting more people. Yeah, I mean, eventually I think we might, and I think it's also a part of the personal interest, like, or the particular interest of an actor who is conducting the space elevator program, like whether they want to send a cargo or people to space, right? It's more like their own interest, right?
Well, I see no reason why we can't use our space elevator that is in transportation. And then at 2,000 kilometers, you run another tether down and you have a honeymoon hotel at 200 kilometers up. Wow. There's no reason why you can't have Strand come down and then have people going up to 200 miles or 200 kilometers and having a hotel there. And, you know, you could put that any place you want up there, but you wouldn't want to get too high because radiation. But, you know, you'd be above the curvature of the Earth. You'd be in complete dark, et cetera, et cetera, et cetera. So we have always thought that if we ran this extra strand down early and ensured that was safe and redundant, we could run people up to a hotel.
This is so interesting. I'm having so much ideas of how, you know, the space elevator would actually work. There will be rest stops in between, and then there will be hotels, and wow. Okay, I should stop actually. And
it is quite a road to imagination, though. I mean, I was visualizing it, and I feel we have to give credit to Pete in that sense, because just the way he is describing it is making it so very clear in the sense of, you know, how it is. I was kind of thinking, you know, the way we have, you know, pilgrimage and how you go to like religious places, you know, on a pilgrim, as a pilgrim. And I feel like space might become like one of those things where, you know, you take the space elevator, you have your hubs, and, you know, you create like a sort of a space journey throughout, and, you know, you could be stopping over at Moon and then, you know, proceeding ahead to Mars. Like he said, it's a train. So you imagine it as like a journey from, you know, one place to another, and look at it as like stations, which is amazing.
And I
want to just sit and like dream about this actively later.
And when you were thinking about pilgrimage, I was thinking about, you know, how, you know, there are like a lot of jokes revolving like how the rich people actually go for the first date. Like they take the helicopter and they drive the helicopter and go around. So imagine having first dates on space, you know, through the space elevator. Wow. That will be so. That will be the cliche takeoff for the next century people, maybe. Oh my God.
Yes,
Okay,
yes.
that
We're
will be
very
like.
sorry, Pete, if you feel we are
Yeah.
just digressing. This just happens with the two of us
So,
when we are
well,
on board.
let me take
Yeah.
you 30 or so years out. One. We've done a paper recently on a magazine called Room. And what we did is we took Buzz Aldrin's cycler concept. Now, Buzz Aldrin's cycler concept, now he got a PhD at Orbitz and he's really, really good at this. The cycler is a big cruise ship that goes around the Earth and around Mars, and then around the Earth and around Mars. And it is a cycle. So it's repetitive. And it goes back and forth. And so he's always claimed that what you do is you take a shuttle up to there, and then you've got a huge cruise ship, and you cruise for 8 months or so. And then you go down to the Mars, and then you wait for the next cruise ship to come by and come home. Well, what we did is we applied an Earth space elevator and a Martian elevator. So you could literally take the taxi from the top of the Earth space elevator to the cruise ship, and then take the cruise ship to Mars, and then take the taxi from the cruise ship to the Martian space elevator, and then go down to the surface. So literally in the future, I see very much transfer of people through space elevators to beat gravity. See, the whole purpose of a space elevator is to beat gravity.
Yeah.
That's what rockets are poor at that. Space elevators are excellent at that. We have to beat gravity. It's a silly terminology, but it's so explanatory. It says what the problem is.
Yeah, exactly. And talking about beating the gravity, let me go to the next question, which is on like, there is a lot of technical aspects to the space elevator, which me and Pooja are still trying to understand. But in simpler terms, like when it comes to physics and engineering, I think that are the most two common branches of science where we use to explain the theory. So what are the basic theories or how the mechanism works in the space elevator in its functioning? Like what are the basic theories when it comes to it?
Okay, there's only one really theory, and it's very simple, but it's a dominant, strong theory, which is amazing and has been proved out. As you take a rock and put it on a string and throw it around your head, like David and Goliath, okay, the rock stays out at the end because it has centrifugal force outward. So the string is taut and it's rotated so that it's spinning around. And so that's the way the space elevator works. We have a 100,000 kilometer long rope, and we have a rock at the other end. Well, we call it a space station, but it's a mass at the other end. And it goes around the Earth in this like path, and it's pulling the tether outward. So there's a continuous force on that, and it's extremely stable. And so the concept is remarkably simple, and it's stable to the nth degree. A lot of dynamics people have tried to show how they might think about how it would go unstable, and they can't do it. It's very stable. So the concept is trivial. Building it is not trivial. We're working on that, but the concept is just a rock and a rope around your head, twirling it around your head.
That is so amazing. I mean, I was just imagining it as you said, and that simples it down so much in my head. In fact, I remember like as a science communicator, sometimes we used to do the same thing, put a string and put like a small ball attached to it with a pen and just like rotate it around and explain how the different planets are moving at different speeds because keeping sun in the middle. And this is somewhat like the same principle that we are kind of using it. And, as the string is longer and you further away you go, the speed is going to be slightly, slower. The moment you're coming like closer, it's going a little faster. So, and we actually even try and do that in, on the kind of chair that I'm sitting on, which is like a chair on wheels. If you just like turn it around, we've all done this at kids. We just like turn it around. If we put our, hands wide open, open, it's usually slowed down. And if we, keep it to ourselves, it's, going faster. So I kind of get the concept, and I think that makes it very simple. Like you said, it's a beautiful, simple concept. But yeah, building that might be, I can't even imagine what it might be to build something, because I think the simpler, the concepts get, the more, deeper your understanding has to be in order to apply them.
Yeah.
So true.
Yeah.
But I like simple. Simple is good.
Yeah.
Exactly.
So that is making me realize, how much of this technology do you think today has already been realized? You said that, we are just about now starting to, develop it. So what is it that has changed and made it possible to develop it now, which we weren't even talking or thinking about 3 years, before? And also in terms of like the financial aspect, like what is the kind of, money we are talking about, and are there people who are investing in it, and what are the different types of countries who are actually thinking about doing this and taking it forward?
Yes, there was a lot of questions, but let me start with the number of countries. There are many, many people. Japan has done a very, very good job, and they have a design, and they just announced a month ago that they're going to build a space elevator for like 2040 to be used to raise space solar power satellites. So they've already committed generically to space elevators to support that mission. The British, the UK, let me be precise. The UK has started a space energy initiative, which requires a lot of space solar power satellites to provide energy to England. And many of them have told me that they really think space elevators would be the way to go. So, we have not broken through to get a commitment or anything, but there are many countries that have done that. Now, India has had some interest, the National Space Society in Mumbai, and I've talked to some of the space generation folks that are in India, and also the SEDS, what's that? Students for Exploration and Development of Space, giving lectures to those troops. So there's a lot of interest at the casual level in India, so that's pretty neat. In the US, we've got a lot of body of knowledge in the International Space Elevator Consortium. If you go to our website, then you can have like 800 references of papers and like 40 videos on the different topics. So there's lots of information on that location, as well as 12, 18-month studies addressing each individual topic. And the one that was fun was the Green Road to Space, where we talked about moving high-level nuclear waste away from the Earth and throwing it into the sun, or space solar power, or doing planetary sunshade. So put a whole bunch of shades between the Earth and the sun and cool the Earth down. So there are lots of good ideas that if you need mass to space, rockets can't really do it. And so we can enable those programs. So that's really pretty exciting. And let's see, what else? What other question did you have there? And, those multiple ones.
Finance is one of the angles.
Okay, yeah. We have done a financial study back in 2014 at the International Academy of Astronautics. And they did a four-year study, and it came up with a number right at $15 to $20 billion. And as far as I can tell, we haven't really moved off that number. The engineering is relatively simple, except for the material, and we're working that. And I've been building spacecraft for 53 years. So I believe we can do all the parts of the space elevator, all of them. That's why I've put my little money into a little company to start building it. And we can do it. Now, we've got a lot of hurdles. We've got a lot of issues. We've got legal and political and country by country and all those other issues that are out there. So there's no doubt about it. It's going to be difficult. But if you said $20 billion, you'd be in the ballpark. But if you were going to put a bridge to San Francisco across the bay, it'd cost you $20 or $30 billion. It's not unheard of to have a transportation system, a permanent bridge that's at least that expensive, if not more.
Yeah. And I guess my last question was about in terms of what has shifted that we can now think about realizing or materializing this technology, which was not the case 3 years ago.
Yes,
Yeah.
I call it the modern day space elevator, and that means the material is ready today. And we have the single crystal graphene in sheets. Now they're only 3 or 4 inches sheets, but they're a single atom thick. It's called two-dimensional materials, X, Y, no Z. Okay, it's a single atom thick. And my friends are setting up a process where they could just continuously put out that single layer out the other end of the production line, and then you add them together and make it 500 layers, and that's the strongest material ever known, and it would sufficiently handle a space elevator.
So safe to say that it is material science actually, and the breakthrough in material science that's helped us to realize this now?
Yes, material science had a tremendous breakthrough. The guys at the University of Manchester won a Nobel Prize 15 years ago discovering this stuff, and they've developed it, and they're well along the way in this stuff, the two-dimensional materials at the University of Manchester, selling it commercially. Now there's three types of two-dimensional material. There's graphite, which is like pencil lead, and that's very, very important for things like sound deadening in all Ford trucks. All Ford trucks have graphite in them. Then we have the two-dimensional material, but it's called polycrystalline. It's like a cobblestone street. The little parts don't combine to each other, but they're all together, and they do a pretty good job for most jobs. But we need a continuous growth of 1 atom thick molecule that's 1 meter wide that continuously grows, and you just pull it out the other end. And that's what we need. And that's what we're in the process, or I should say the University of Manchester and other places, General Graphene in Tennessee are doing. So there are other places. We don't know what's going on in China, in India, or Japan, but the material is the key. And it's going fast.
That is amazing. Thank you so much for this insight. I'm going to read up a little more on this.
Exactly. I'm still thinking about the material, saying that there is no Z, like it's a 2D material, like, it's that thin. I'm like, okay, I mean, that's actually something pretty interesting. And that again goes back to my last question for this episode. Like, since we have talked about all of it, like from the origin to the developments, financial aspects, and again, the material that we are using in a space elevator, I cannot stop, but call me a pessimistic, but I cannot stop but think, like, what happens, like, if this elevator breaks? Like, what's going to happen?
Everybody asks that question. And if you're a bridge builder, you know that everybody asks, is it going to fall down?
Yeah.
So we've learned over 2,000 years doing bridges that we know how to do bridges. And we have to figure out what the threats are, and then we've got to design them to modify the threats. Now, the beauty is we have computers that are really, really good and can really do stress levels for all the components. And if you talk about anybody building airplanes or automobiles or new electric batteries and stuff, they're looking at the breakage potential on everything. And so we would do the same thing. We have the same analysis on that, and we have a position that we will not have it broken on our watch. We're going to build it and it's not going to break. Now, it could break. I mean, we all know that.
Yeah.
It's probably going to break down in the bottom 2,000 kilometers, which is where the space debris is. So if it's going to have a break, it might break there. If it does, it won't be catastrophic. From the geosynchronous level at 36,000 kilometers altitude, you reel out real fast. And then you reel out the tether until it gets down there, and then you grab it and pull it in. I like the idea of at 2,000 kilometers, since it's the riskiest parts below that, is instead of having 1 strand, let's put 5 strands down. And then we have the main strand where we go up and down, but the other 6 are all backup, or other 5, whatever. You have multiple legs down there below the high threat area. So we really have thought about this a lot. And the answer is, my bridge will not fall down. I mean, anybody does infrastructure, buildings, bridges, whatever, cruise ships, we're not going to let them break. I mean, the designers go out of their way to make sure it's redundant and it's reliable and it's strong and all that kind of stuff. So Yeah, a lot of people like to think about the catastrophe, and most movies that have space elevators have the catastrophe in there, but I don't think
Yeah.
so. We're engineers, bridge builders. Think of us as a
Hmm.
bridge. We won't let it fail.
And I just like the idea of how he mentioned, like, in case if it breaks, we have technologies to solve that issue at that same within the short time of span or whatever. We have tethers to connect it back to the original position, and we can resume the activities even if there is a breakage. So that shows that we are ready, or we are kind of there, like the mankind is capable of building this space elevator, and we have the material, we are ready, we know the theories, we just have to implement it, make it a practical way of doing it, right? Yeah.
Alina, I also feel that number one, I feel when we're talking about any sort of a bridge or any sort of an elevator, the another angle which is very important to consider is maintenance. We have the issue of breaking when it is not maintained, and I feel for something which will be used that often, and because there is that scare of safety, I'm pretty sure they would have already thought through maintenance procedures, to make sure that it is all in place. And as long as it's maintained, I don't see us like having those issues. You have bridges which are surviving for like years and years together. So
Exactly.
I don't see that happening. Plus, I feel like usually when it comes to like space and air and space rather, there is always this question in terms of like safety. But just to throw in some numbers and facts, we actually have more road accidents than we have plane accidents. But despite that, people have fear about plane accidents. And I feel in terms of space as well, that will be applicable because we think so much that the possibility of that will be lesser. It's just a connotation in our head that, it's a scare because it's not so common. Once it becomes common, you don't have that scare. Like people don't have that scare of, oh, will my airplane crash now? People take flights all the time, but that wasn't the case when it just started out. So I guess that's just going to be something that will span out of some time. If not, Alina and me are always willing to test ourselves and go first to prove to be
so. Absolutely. I mean, we can do that. I mean,
the real kicker is whenever people start thinking about the negative side, you have to think about the positive side. And the space elevator is so transformational and would change everything. The ability to do more mass per year than we have in the last 65 years is a statement that blows people's mind, because we've been using rockets and they've been putting up a little bit here and a little bit there, and they just can't lift very much. Whereas space elevators transform to a permanent train, and all you do is put stuff on it and just keep it going. I mean, it's transportation versus individual events.
And it's eco-friendly. It uses renewable energy source.
Definitely.
And there is no debris or anything produced. Like for a rocket, it launches and some part falls down and then it gets there. And for space elevator, there is nothing of that sort. Like except you need like a little electricity to run it, and that too it's taking from the solar power, and you just reach your destiny, and it's faster than rockets. It takes lesser time to reach your destination. And wow, the only thing now is to prepare the space elevator, and I really, really wish that it will happen and we will be able to see it as soon as possible, like within the next 20 years or so, right?
I figure next 17 to 20 years we'll have a space elevator. I'm hoping to live long enough to see the $18 billion committed to it. As soon as that commitment is there, I can say, okay, I've done my job. So I'm working on making the engineering solid, so then people will say, oh, it's remarkable, let's do it. And then they can put the money. The money doesn't scare anybody in the sense of its big numbers, because we're talking infrastructure, and people, when they're talking infrastructure, don't use little, startup angels or anything like that. We use phenomenal people with foresight that look at the future and say, we need to do it today and spend a lot of money for 20 years, and then we'll make gargantuan of money later. So it's you have to think differently on space elevators.
Exactly.
And I feel like I'm so happy I was a part of this and I got the opportunity to speak with you about space elevators, because I feel like I have the last 30 to 40 minutes have been a sort of a trailer into the future and how space industry is going to look 20 years from now. I think you've kind of broken that and like sold us that dream. And if we're sold, I'm pretty sure others will get along the way as well.
Same. I mean, I was thinking this episode will be more kind of like a fictional way of putting things, because space elevator is not something that we talk on a day-to-day basis. Like when you talk about space, people talk about rockets and space shuttles, but not space elevators. But now thinking that, it's already been realized in different parts of the world, there are people working behind to achieve this dream, makes me think that, okay, dreams and fictions do come true. I mean, we should be true.
Yeah. And it usually in space, it comes true if you can move mass. The problem is moving mass. And that's the biggie. So we want to have a dual space access where we work with rockets and we do the big mass and they do people, something like that. We work collaboratively with them. And then with that type of stuff, we can transform the movement off planet and we can enable saving the planet's atmosphere. So we have so many strengths that people don't talk about. They just look at, well, it's a little thing and doing that. No, we transform the way people go to space.
Yeah, I think we need a Christopher Nolan movie to explain this to most of the people, because I think then everyone will understand, and then everyone will be supporting the idea of space elevators, I think.
Well, I hope so, yeah. we got a little video at our website, both ISEC and Galactic Harbor websites, a little video that's 3 minutes long, and it's very, very good. It explains the transportation side. So, if you want to,
and
that.
Yeah, for the audience, I'll make sure that, every links will be mentioned in the description below. So check it out to know more about space elevators and about ISEC. And also, we have this wonderful opportunity with Dr. Peter Swan this Saturday, 9th of April, 6:30 p.m. IST on Clubhouse, where you can directly interact with him and give him your questions about, the space elevator, of course. And he will be more than happy to explain it to you and to answer your questions. Right, Pooja?
Absolutely. I am personally going to make sure that I could be there and I can pick his brain more on a lot of other questions. So don't miss out on this opportunity to speak about space elevator and like space engineering and so many other things in general. And me and Alina will always be around to make sure that there are silly questions that are asked, because both of us are the ones who always fill in the quota for that. Along with that, I will just say keep smurfing, and we'll see you soon.
Yep, and see you all on 6:30 p.m. IST, 9th of April on Space Smurfs Clubhouse. Till then, this is Alina and
this is Pooja, your wandering stargazer.
We both are signing out. Until then, be safe, keep smurfing. Bye-bye.
Bye.
Bye.